This will be the review of the midterm exam for 2013, C326. First question, you live in rural central Pennsylvania and you've got a shallow groundwater well and it's your drinking water, and considering leasing your mineral rights for gas exploration. So that likely means that hydraulic fracturing in the Marcellus Shale play will come into effect. So I was looking, this is one student's work, so looking at environmental, economic, and societal impacts. And so environmental, obviously there could be some concerns with the construction, the hydraulic fracturing processes, contamination of groundwater supplies, trucks, issues with neighbors, and so on. So there's a lot of things that I was looking for in this. Economics, certainly if you've got mineral rights, that's going to be a certainly will be a plus to your bank account. We've got the pros and cons. I was looking for some pros and cons with this. And then societal impacts. It could be some issues with your neighbors. If some have mineral rights, some do not. You can have profound changes in the, let's say, the town that you live in. Lots of people from outside coming to work there, and there could be some pros and cons. Some of the restaurants and businesses might do quite well, but there's going to likely be increased crime and so on and so forth. So I was looking for a pretty detailed discussion, and this is a good example here for that. The second problem, bismuth 210 is a half-life of 4.85 days. And so I want to find out if we got 10 grams of it now, how much would we have left in 7 days? And so let me find this problem. I'll pause for a second. And so this would be a first order. It's an assumption, certainly an assumption you need to make. This would be a first order half-life equation because of mineral or microbial degradation or growth typically is an exponential rate. And so there were two versions of the equation that you could have chosen from, but the best would have been the first order half-life equation, and you would come up with approximately using this version, initially solving for K at 0.14 per day, and then solving for that concentration at that particular time, 3.68 grams. The second problem was to look at human growth from 6.3 billion in 2000 to the ultimate population of 10.3 billion, and that 10.3 would be the K value. Now this is logistic growth model. A number of you assume this was exponential growth, but it actually has a cap with that, and so it's a logistic growth, and so you would be using this equation that you see up here that's also in your textbook. Mu net was given, which is the mu max minus KD. Put those values in. A number of you solved this by hand at first, or in a MathCAD or Excel, and calculated the specific parameters of when would the population reach 9 billion, about 15.67 years. Part C, what would be the population in 2050? And so you'd solve for time, or excuse me, solve for XT, and that would be looks like 10 point, what was that, 10.3, no, 10.21 billion or 10.24 billion. And then you plot it, and so you set up this axis here that has the year, the time, xt, and it would go up at this rate up to that maximum, and you'd see it flatline up at that point. It couldn't go higher than 10.3 billion. So a number of you had some challenging times graphing this type of problem, essentially putting the values into the equation that you see here and solving for that. So be sure you practice with Excel and know how to solve things, know how to graph and plot things. It's certainly going to come in handy in the future parts of your academic career at the School of Mines. The next problem was a lagoon problem, and so we're looking at the CSTR. We have first part was to graph this, show the inputs and outputs that's shown on here, and then solve 0 equals m dot in minus m dot out plus or minus m dot reaction. put in the values, got to change some units in here and solve for the volume, and you should get a volume of 8.6 cubic meters. 8.6 million cubic meters would be the volume of the pond that would be required for this this problem. And the last problem was the hardness problem. Let's see if I can find that. Alright, so hardness problem. I give you a lot of extraneous information, but you essentially have to calculate hardness as the sum of the divalent cations in the water. So that would be magnesium, magnesium, and that would be calcium. And so we've got magnesium at 19 milligrams per liter, calcium at 35 milligrams per liter. Need to convert that to as CaCO3. So again, that goes so multiplying by 50 and dividing by the molecular weight divided by the number of equivalents, which is 2, and you get 78.1, 87.3. The sum would be about 165.5 or so milligrams as CaCO3. So again, it's just the magnesium and calcium 2+, some of the divalent cations. And then you had the environmental topic of the day. So please come see me if you have some questions about your scores. And overall, I think the class did quite well.